All right, graphing parabolas in vertex form. I think vertex form is my favorite because I think that it's the easiest. It really doesn't require a lot of extra solving. So really what you have to remember is that vertex form gives you the vertex. A is still our leading coefficient. It still tells us if it opens up or down, depending on if it's positive or negative, and if it's wide or narrow, depending on if it's greater than 1 or less than 1. H is our horizontal shift. That's our x coordinate of our vertex. So that's our x of the vertex. And K is the vertical shift. So H shifts it right and left. K is the vertical shift. It shifts it up and down. That's our y of our vertex. So if we take the general form, we're going to take out our vertex. It's going to become HK. So notice that H comes out as positive and it is negative in the equation. So H is always opposite when it comes out. So that's one thing to just note. So let's do a couple examples. So graphing this equation using the parent function. So our vertex here, our H will be -3, which will be our x coordinate of our vertex, and our -4 will be our k value. So our HK is going to be -3, -4. That's our that's our vertex. Sorry. Getting flustered here, and our A value is 2. So start by graphing that vertex, -3, -4. Then we can use our parent function pattern again. Usually our parent function pattern is up 1 over 1, up 2 over 4, up 3 over 9. I totally screwed that up. Maybe I should just start over. It was over and up is what I meant to say. It's getting late, I'm sorry. The A value in this one is 2 though, so this will all be doubled. So it'll be 2, 8, and 18. So multiplying the middle column by 2, now that middle column is done. So now instead of going over 1, up 1, we go over 1, up 2. From the vertex, over 1, up 2. Reflected over that axis of symmetry. Should have mentioned that maybe. Our axis of symmetry will be the equation x equals h, which is just x equals -3. It's whatever our x coordinate of the vertex is. So this time we kind of go backwards. We're given the vertex, so that tells us our axis of symmetry. So over 2 up 8 from the vertex. And then reflected over. And over 3 up to 18 most likely won't fit on my graph, and I don't really need it anyway, so I'm going to try just to make that maybe just a little better. There we go. All right, I have 3 examples, so that was a little choppy. Let's do another one. Okay. The standard form is the ax minus h squared plus k. Our vertex is our hk value. K always comes out as opposite. It's negative in the equation, so it'll be a +2. K is always the same. It'll be 2, 6. So 2, 6 is our vertex. Then our a value here is just a negative out front, so our a value is -1. So that means it's going to follow the same parent function pattern except for opening down. So it'll be over 1, up 1, over 2, up 4, over 3, up 9. But instead of going up, it'll go over 1, down 1, over 2, down 2, over 2, down 2, over 3, down 3. So from the vertex, over 1, down 1. I'm going to draw in my axis of symmetry. Again, the axis of symmetry will be the equation x equals 2. That's our x value. So I can reflect that over 2, down 2, reflected over 3, down 3, reflected over 3, down 3. Okay. I was looking a little There we go. I was looking a little wide. I think it's just because I'm really zoomed in here. And that's it for vertex form. It's pretty straightforward. Oh, this is a reminder, standard form. So I'm just going to keep it with vertex form for this video. So find the vertex, find the a value, use your parent function patterns to graph, and then draw the axis of symmetry in there so that you can reflect it over. That's it.